Students, if you like this video, please subscribe and share it. Don't forget to like it. Now I am going on. Topic is permutations. Concept is circular permutation. What is a circular permutation? Circular permutation means the objects are arranged in a circle or closed curve path is called a circular permutation. Now circular permutations maximum based on two formulae. Now first one is the number of circular permutations taken all at a time is n minus 1 factorial. The number of circular permutations n dissimilar things taken all at a time is n minus 1 factorial. Okay, second one, the number of circular permutations clockwise or anti-clockwise. Example, now chains of beads, garlands of flowers, etc. Now using formula half into n minus 1 factorial, half into n minus 1 factorial. Okay, now here first one, the number of ways in which 6 men and 5 women can dine at a round table, no two women are sit together. No two women are sit together means, now first we arranged 6 men arranged at a round table. Now 6 men. Now first we arrange 6 men can be arranged at a round table. Now 6 minus 1 factorial. 6 minus 1 factorial into, now there are 6 gaps between them. These 6 gaps can be filled with remaining 5 women in 6p 5 ways. In 6p 5 ways. Therefore, the required number of arrangements is equal to 6 minus 1 factorial, 5 factorial into, now 6p5 is a 6 factorial. Therefore, 6 factorial into 5 factorial. First one is the correct one. First one is the next one. The number of ways in which 7 men be seated at a round table show that no particular men are side by side. No particular men are side by side means required arrangements is equal to total arrangements minus 2 persons side by side. Total arrangements minus 2 persons side by side. First here, total arrangements means 7 men can be arranged in a circular table. 7 minus 1 factorial, 6 factorial minus 2 persons side by side. Now P1, P2 are 2 persons. Side by side means now you treat a 1 unit. Now 1 unit plus remaining 5 persons. Total 6 persons can be arranged in a circular table. 6 minus 1 factorial. Now here 2 particular persons can be arranged themselves 2 factorial ways. Now 5 factorial into 2 factorial, 2 particular persons side by side. Therefore now here 5 factorial into 2 factorial. Now here 5 factorial common, 6 minus 2 factorial value 2, 120 into 4 is equal to 480. Therefore, required number of arrangements is equal to 480. Option 4 is the correct one. Next one, the number of ways in which 6 gentlemen and 3 ladies be seated at a round table show that every gentleman may have a lady by his side is. Now 6 gentlemen. Now G1, G2, G3, G4, G5 and G6. Now according to given conditions, now here three ladies are given. Now first we arrange lady 1, L1, L2, L3. Now this is one of the way. And here also G1, G2, G3, G4, G5, G6. And here also L1, L2, now here also L1, L2, L3. This is the one of the way. Now three ladies can be arranged in. Now this is one of the way and another way is this one. Now required arrangements is equal to, first here 6 gentlemen can be arranged a round table 6 minus 1 factorial into, now 2 into this is one way and another way is this one, 2 into. Now three ladies can be arranged side by side. Now here L1, L2, L3 and here also L1, L2, L3. Now three ladies can be arranged in 3 factorial. Now 5 factorial into 2 into 6. Now 120 into 12 is equal to 1440. Now option 1 is the correct one. Option 1 is the next one. The number of ways in which 8 red roses and 5 white roses of different sizes can be made out of from the garland. Show that no 2 white roses come together. No 2 white roses come together means first we arrange it in garland. Now 8 red roses. Now R1, R2, R3, R4, R5, R6, R7, R8. Now 8 red roses can be arranged in garland. Now required arrangements 1 by 2 into 8 minus 1 factorial. 1 by 2 into 8 minus 1 factorial. Now there are 8 gaps between them. These 8 gaps can be filled with remaining 5 white roses in 8p5. Now therefore required arrangements is equal to 1 by 2 into 7 factorial into 8p5. Now 7 factorial by 2 into 8p5. Option 2 is the correct one. Next one, 3 boys and 3 girls are to be seated around table in a circle. Among them, the boy X does not want to any girl neighbor and the girl does not want to any boy neighbor. The number of such arrangements possible is, now 3 girls and 3 boys. Now around a circle. Now here 1, 2, 3 boys. Now 3 girls. Three boys and 3 girls. Now boy X will have neighbors as boys 1 and 2. Boys 1 and 2. and girl Y will have neighbors as girl 3 and 4. Now boy X will have neighbors as boys 1 and 2, and here also girls Y will have neighbors as 3 and 4. Now here 1 and 2 can be arranged, 1 and 2 can be arranged 2p2 is equal to 2 factorial ways, and here also 3 and 4 can be arranged. Now here 3 and 4 can be arranged 2p2 is equal to 2 factorial ways. Therefore required arrangements is equal to required arrangements is equal to required arrangements is equal to 2 into 2 is equal to 4 ways. 2 into 2 is equal to 4 ways. Therefore option 2 is the one. 20 persons are invited for a party. The different number of ways in which they can be seated in a circular table with two particular persons seated on either side of the host is. Now here two particular persons either side of the host is means now two particular persons either side of the host treat a 1 unit. Now 1 unit plus remaining 18 persons, total 19 persons can be arranged a round table or circular table 19 minus 1 factorial. And also two particular persons can be arranged in either side of the host 2 factorial ways is equal to 18 factorial into 2 factorial. Therefore required arrangements is equal to required number of arrangements is equal to 18 factorial into 2 factorial. Option 2 is the correct one.